All right, let's get a new section we call General Chemistry Part 16. We've been preparing for today, and all of these knowledge we learned in the past, the matter of ions, cation, anion, compound, molecule, physical states, the mole concept, the gram formula, weight, everything now come to play all together in this section we call chemical reaction. Now, in order to get into the stoichiometry, which is the quantitative analysis of a chemical reaction, we have to start from what is chemical reaction, what's its definition, and what chemical reaction do, right? And then what is the force drives the chemical reaction to happen, and what is the chemical reaction conditions. All these we already briefly, not really briefly, we detailed actually at the very early stage of this course and the beginning of a couple of weeks. And if you still remember, we're going to mention that again briefly. And then we are into the arena. It's a little different than just introduce individual concept, not related. Now we are going to put everything we learned in the past together to get into the chemical reaction concept. Alright, so what is the definition of chemical reactions? Alright, as I say here, a chemical reaction is considered as the chemical process. What is a chemical process? In which different driving force. Now we're going to talk about driving force. You are wondering what happens if this react with the other chemical compound will form the new products. Now there is some kind of a driving force behind it. Alright, we're not going to get so completely deep enough, but we're going to introduce that quite detailed. Okay, and those driving forces act upon chemical substances we call reactants. Now before you mix, we don't try to not using mixing. We try to use the reaction, right? When the compound A and the compound B, they meet in the solution or in under certain condition, they start to react with each other. Now we don't say mix each other, right? And we say react each other. So the reactants would spontaneously means automatically, or sometimes is not completely spontaneous because it's spontaneous to react with each other, but it takes so long. So slow the reaction occurs, but it takes so long, so we have to speed up by adding something in there to push or stimulate or speed up the process of reaction process. So under certain conditions, right? And those substances will undergo their composition change. Now we talk about chemicals, right? We talk about chemical compound. What is the major concept in the chemical compound we learned in the past? Chemistry is what? Chemistry is study of matter and its change, right? Right? Under what? Under a concept we call proportionality, right? In proportion based on what? Based on number of moles, right? M-O-L-E-S. So that's where we are clearly, repeatedly mentioned and studied. So we should have no problem when you run into these kind of terms, right? So we talk about, right, composition change. The composition change means what? The atoms of the compounds, right, still there, but no longer combined with another, the compound to another other atoms for different elements, but they combine with, they dissociate, separate it in a solution. Normally we talk about aqueous solution, and then to combine with other species, other cation, anion, or molecules, and then they become a new compound. The total number of atoms of different elements in the entire reaction process stay intact, doesn't change. But they reorganize, right? So reorganize the reactants as chemical substances or chemical compound no longer exist after reaction. Before the reaction start, they do have their own characteristics. But after they react with each other, and then the reactant disappears. And the new compound called products generated or produced. That is the process we call chemical reaction. All right, chemical reaction. So let's have a small review in the past. So we talked about chemical reaction. We use that, right? We say, okay, if you have a chemical compound, just a one compound, right, as reactant, right? So we start from there. So example, right? We did in the past. Say this chemical compound has a chemical formula as CHEMISTRY, right? RY, and it's solid, right? Now, when you write chemical reactions, equation you have to specifically emphasize the physical state that we mentioned so many times, right? Then this compound is called chemistry. Now, S stands solid. So what here means you want to learn solid chemistry, right? You want to learn solid chemistry and do good, right, in this course, and learn solid chemistry, no mistake, correct, right? Correct chemistry chemical concept. All right. The chemistry come from where? Now let me put this. It's a one-way or direction, and then become a products. The first one we call CHEM. CHEM 141, right? And they say, okay, its physical state is liquid, right? And then you have another product produced from this reaction is called IS, right? You remember in the periodic table there's hundreds of elements. They have one letter or two letters, right? The first letter capitalized, the second letter is italic. So that could be a new element, right? Okay, it could be a gas phase in this particular case, and then the third products also come along, and it's a chemical formula is DRY. Now that makes chemistry, right? Chem is tri. We talked about this already. Now the last one also has physical state. Now I'll put very clearly in the past. We learned a long time ago, and in chemistry, the number 4th most important physical state is not a plasma, it's aqueous. Aqueous means what? Water-based solution, right? Millions of a chemical process occurred in the aqueous solution, so AQs. So then if I know the process under what kind of driving force, we talk driving force. In this particular, it's just like an analogy, right? You want to learn solid chemistry, you have to do what? You have to try. You have to try error, and if you don't understand, read the book again and again, over again, and try to understand. I've said it so many times, reading textbook of science is not reading a novel of triangular love stories, right? So you don't just get the results by flipping page so fast. It won't get you anything, right? You have to read over and over again, stop, think, and then try to think deeper, and then try to understand. So you may have the driving force. The driving force is what? Right? Driving force, let me put here. Driving force is what? To get an A, right? Get an A in the class. Correct? You don't want to get F. Right? And this could be a reaction. And it's also involved in writing chemical reaction in the future. You're learning thermochemistry and any other organic chemistry, a lot of, and you may involve energy. So sometimes you may involve the enthalpy, right? Enthalpy with a certain amount. We don't know. That's an analogy, right? So it could be what? Could be positive. Let's put it this way. Could be positive or negative, right? So positive means always in 0, right? And a certain value, right? That's energy, all right? If it's a positive, it's going to be what? Positive will be what? Endothermic, and negative will be what? Exothermic. We talked about this before. So, in this particular case, and normally I said in the past, you may involve certain condition, right here, certain condition. It's not spontaneously go fast enough, so you try to speed up the reaction. You put some heat in there, triangle means heat, right? And heat up the reaction chamber. If it's a gas, the gas, in this case it's not gas. This is what? This is chemical reaction we call one reactants produce 3 products. That's a decomposition reaction. What do you understand about decomposition? If you don't understand, let's just give you this simple example. If you buy a dozen of eggs, right? You forgot to put in freezer or refrigerator, right? and then 1 week later you feel the room filled with some kind of foul smell, right? Which is rotten egg smell, right? The hydrogen sulfide, and then so it come out from the rotten egg. Now egg is no longer good, right? And it cannot be used to, you cannot eat again anymore because it's getting rotten. And then the composition of the protein inside the egg getting decomposed, right? Decomposed. So decomposition normally is an endothermic process. It absorbs some heat from the room, right? It's not, you did not put it in the refrigerator, so it's not cooling down to maintain a certain low temperature and then still fresh. It's getting more energy from the ambient air from the surroundings, getting those energy, and then the reaction goes through a decomposition process and decompose protein and getting rotten egg. So that is the heat involved. You absorb heat, right? That's it. And then if you put in a refrigerator, the egg can last weeks long without getting rotten. But if you left outside getting rotten so quick, that means what? You speed up decomposition reaction if you put energy in there. Do you understand this? So that's it, your energy input into the egg getting rotten much faster than you refrigerate, right? That's heat. Sometimes we put the catalyst like a platinum, right, and those rare metal and the nickel, those catalysts to speed up. So that is the whole thing we need. Now, but also when you talk about this is generalized. Just I normally want to get something difficult to characterize, but I try to characterize into a generalized format. And it's also fun enough, for this case it's fun, and then you are able to memorize longer, right? Memorize longer. So we use this all the time in my class. And then, but this is just a generalized format of generalized chemical reaction equation, right? But it represents a couple of things, right? Couple of things. Now it represents what? It represents a couple of things, right? Number A, right? You have to know what? You have to know the proper chemical formula for reactants products, right? Know the correct chemical formula of the reactants and the products, right? Now you have to know their composition. Water is H2O, not H2O2. That's a hydrogen peroxide, right? You have to know that. You got one oxygen only, right? And ammonia is NH3, non-ammonium. We already mentioned that, NH4, 1 plus. That's totally different. One is a molecule, one is cation, right? Called ammonium cation, right? It's a polyatomic cation. We mentioned that in the previous section. Talk about electronegativities and the molecular compounds and their polarity, those things, right? Now, and that's number one. And the number two, right? We need to know the direction, right? The direction of the process, right? Either one way called irreversible, right, as one direction, or reversible. Now that is going to be both direction. We use double arrow, right? That is very important. And in the past, we mentioned that Haber process, right? The Haber process, for instance, the Haber process. Haber process for what? To make ammonia, right? Make ammonia. So we understand that, right? So it's nitrogen, right, gas, react with hydrogen gas, right? Right, that's going to be 3, and then it's double, and again H and 3, so that's 2. So that's also gas, right? And then this reaction make a lot of ammonia gas, and then we made ammonia gas into ammonium nitrate, ammonia chloride. Those are fertilizers, and then we are able to have more food. That happened at the turn of last century, before 1900 or after 1900. He was a German chemist, right? He's the mentor of Einstein, right? He discovered this process, and under very, very critical condition, I think it's about 500 degrees Celsius and 200 atm at high pressure and high temperature. Right? And otherwise, it won't happen. Let me make this a little bit clearer here for you to take notes, whatever you want to. So I think it's 500 degrees Celsius and 200 atm pressure, and then this mainly goes to the ammonia in this way, and the very small tendency to go back to nitrogen gas and hydrogen gas separated. Those don't make a fertilizer individually until they combine into ammonia, and H3 become fertilizer, the components to make the fertilizer. So, but it's not easy. That's why we did not have enough food, right? A lot of people died of hunger a long time ago, right? So then we have to know. We have also to know very clear the physical state. Physical states of the reactants and products. Now this is sometimes sadly omitted by a lot of chemical educators. They don't even care their physical state. When they come to the point to introduce ion equation or net ion equation, then they're stuck. Because the physical states only that time shows its important, their importance, to help you to understand what those species are identical or not. If they are identical, you are able to cancel on both sides of equal sign, the reaction arrow or equal sign. Otherwise, you cannot cancel because they are not the same species. We're going to get in there. All right, we're going to get in there. And that's the chemical formula and the process directions. Of course, the another one is the coefficient of what? Of the balanced chemical reaction equation, right? So normally, what is coefficient? You balance chemical reaction. In this particular case, it is a balanced chemical reaction. What is balanced equation? Was one chemistry, CHEMISTRY, decomposed into one product called CHEM. We took the first 4 letters part, and the second one is IS, the second part is number 5, number 6, and TRY, the last 3 letters. So they are all equal, right? So 1-to-1 ratio, so that's already balanced. In this particular case, right? In this particular case, right? In example, right? In the example, so we have, what is that? 1-to-1-to-1-to-1 ratio. This is reactants, right? This is a reactant. That's a reactants right here. And those were the products. They are what? They are mole ratio, right? Coefficient. What? Equation which represent what? That is very important right here. What is the coefficient, right? Is in above. above, let me rewrite it. In the above reaction, right? And for the mole ratio, right, between the reactants and the products, right? Product as what? 1 to 1 to 1 to 1. That is a particular case, but not always the same, right? You have 1 to 2. So for instance, here's what? Here's 1 to 3, right? To 2. That's the mole ratio. 1 mole of nitrogen gas, right, is able to completely react with 3 mole of hydrogen gas, right, in order to produce exactly 2 mole of ammonia gas. If it's balanced or not, we check. The hydrogen, 6 of them. Nitrogen, 2 of them. So that's balanced. What's the coefficient? 1, 3, 2. The 1 doesn't show because we omit it, right? So, but you write down the mole ratio, 1 to 3 to 2. 1 mole, 3 mole, and 2 mole. That's the mole ratio. That is quite important. The most important, right? The vital important info for what? Information. For stoichiometry analysis. It's an analysis or calculation. We're going to get in there. All right. So now number 4 and number 5. Of course, we already mentioned, right? Number 5. The reaction condition, right? We already mentioned that is the heating, the catalyst, right, etc. All right, that's probably most important thing I listed here. Now, one thing I have to mention, again, all right? Again, the physical state. Don't forget, this cannot be the importance of physical state should never be underestimated. You have to be very careful to be very clear on the physical state in writing chemical reaction equation, either balanced or not. That is quite important because when you get to the point, we want to write a net equation, try to find out a spectator which does not, right, and involve the reaction, and then we can cancel them out, or they are not spectators, so you cannot cancel out on both sides because they have different physical state, right? Now, and by the way, we may have put one more point here, is now, right, determination on the reaction, right, occurred or not by the products. In other words, sometimes the products does not really come out as a product. They stay in the solution as cation anions. They are not. There's no driving force to force them to form a new substances, right? So we cannot say that that is chemical reaction, because that is not chemical reaction. Because chemical reaction always have to work, have to produce products, new products with different composition from the atoms of different elements from the reactants. Now, you may say that is a chemical process or chemical change. Yes, the difference between chemical products and chemical change is such. If you consider there are different species, you consider the chemical change is involved. But if the different species cannot be produced or get it out, the reaction stay in the solution, you cannot make them into new compounds to get them, then that is not considered as a chemical reaction products. So then you have to know this is what? This is either only form new species in the solution, right? Via we call chemical change. A chemical change. That's chemical change. Now I'll give you the example. Or a new product can be obtained via a reaction. Now, what is chemical change? I'll give you an example on this side. All right, for instance, this is chemical change, not physical change. Let me specify this. Now, example. Let me use this side example. Right, the chemical change or physical change. Let's judge. If you put table salt, NaCl, right? Table salt. You put table salt, NaCl solid, right? You dissolve in water, right? So the water is not considered as one of the reactants, but it's the water. You dissolve the salt into the water, becomes saline solution. So H2O right here, liquid. Now when you produce the table salt, dissolve in the water, then dissociate into what? It dissolve and dissociate. It dissolve and dissociate, right? The dissolve dissociate become what? Ionized. So become AQ, and the 1 plus Cl AQ 1 minus. Now this is a process we call chemical change. This is the beginning species, NaCl, solid, in the water, into the water. What is what? Water is polar molecule. Now time's almost up. We're gonna next section, part 2. We're gonna start with the polarity, polar molecule of water, and then we get into understanding of the aqueous solution reaction. Water has a strong power to split the Na cation and the Cl anion into its solvent solution, water, and they become wandering around the water molecules. They are cation anion pairs. So in the water solution, the aqueous solution, it becomes aqueous cation Na plus 1 and the Cl minus 1 minus cation anion. That's called dissociation. I'll call it ionization or dissociation or self-ionization process. It is a chemical change, not a physical change, because we talk about three different species. NaCl is solid, it's totally different from Na 1 plus aqueous and the Cl 1 minus aqueous. Time is up, and then we continue next session. All right, it's over 10 seconds. Now I'm going to erase this. All right.